Hello everyone, in this video we are going to see linked list merge k sorted linked list. We are given several linked lists, its count is k. So this individual linked list is in incremental order, it's sorted. We have to merge all of these nodes in a one full linked list. Okay, that's the question. So how we are going to solve this problem is, here is my code snippet for helping me to solve this problem. So this is a bit complicated, and this is the most frequently asked question in the second level of interviews. So watch this carefully. Okay, I have vector of linked list pointers. So I can expect one vector, and that linked list node pointer will be there. So each represent a head of the individual linked list. Okay, how I am going to solve this problem is, I'm going to find out which is the minimum of the three linked list pointers. Here you can see it standing at the head, so I can check the list of 1, 2, 3. Out of this, which one is the smallest one? Here you can see this one is the smallest one, so I can take this node and construct my final list, and I can move this, which means I can move this one to next. In the next iteration, I'm going to take this one and this and this. Out of this this one is the minimum, so I'll take this and I'll move this one to next position. In third iteration, I'll take this one, this 4, 5 and 3. Out of this 3 is the minimum, so I'll move this one. So likewise, I'll iterate all of these lists individually. You can see in this one will go like this, and 2 also will parallelly goes and reaches its end. So once it reaches the end, we can just skip it because nothing is there. Here it is null. Okay, this is also reached here. You can see this 1 reached the end and 2 reached the end. So 3, when it reaches the end, whatever is there, we can just continue with that. We don't need to compare anything, and ultimately we have to return that head node as a result. Okay, we'll see the code for this. Okay, first line is my answer, what list node it's I initialize to null, and next is, here we have n, which means the number of linked list in that. You can take that vector size as a list dot size, and if no lists are there, list pointers are there, you can just return it as and this null as an answer because nothing is there. Okay, in this while loop, I'm going to continue until my all nodes are processed. So I'll give while true, and here this snippet is, I'm going to find out the minimum one. I'll take the first one, this first one as j equals to 0. I'll take the first one, whatever it's standing, even though it is null also, we'll take that. I'll take the first one and I'll compare this 0th list against all my list. So that's what's written here. If that list is null, which means this I equal to 1, from 1 to n will travel, because I have taken this first one already, from 1 to n until the number of all this 1, 2, 3, and if that is null, we can just continue that. And if j is null, in case we take this 0 but nothing is there in that 0, that case you can just give that one as 1. Whatever it's coming, that j is 1, you can give, but here we can't compare because that data will not be a greater one, because it will be a equal one. Okay, that list also is not null and j also is not null. We have 1 and 2. Here we compare. When it is satisfying this criteria, we'll move that to j. Okay, we have to just find that, and if that list j it's nowhere it existing means we have processed all the nodes, so that time we can exit. And if that answer first time I'm inserting here, you can see this answer is initialized to null. So if that answer is null, you can just give that list of j, the first node whatever it's taking, to j, and ptr for the processing the next pointer. First it's say it's for just traveling that, because we need to return this answer. So it's answer is like a head, and ptr is for like current pointer to travel. Okay, first time if I'm not inserting, then ptr should go to the next one. So for from the end we can see list of j is assigned to this ptr of next, and this ptr of next is assigned to ptr, so that the ptr will advance us to the next position. And once we process this current list, and we'll move to the next one. It was here, once that process done we moved like this. So whatever the node is having the minimum or maximum value, you have to just travel to the next one. So that's the reason it's list of j's, next is list of j. Okay, now we'll implement the same code in our Visual Studio Code, and we'll find out whether our answer is coming perfectly or not. Okay, here is my necessary importing statements, and this is my class node definitions, and this is my driver functions to do this operations. Okay, and in int main function I have three lists, and I appended few items in this, and I printed. So we just run this and see this what's the data it has. Here you can see 0 1 2. If we fully merge this, we have to get from 0 to 10. Okay, now it's list node. I'll return this pointer. So list node star merge k list, and it expects the vector of list node pointer, and I'll pass the same reference so that I can make my all changes in directly here itself. Okay, now I need two pointers. First list node answer as null, and ptr for traversal as null. Okay, now I'll get this list size int n equal to list dot size. If this is 0 and is 0, I just return that answer as null itself. Now I have to continue while true, and I just need a position variable called j, and I have to travel all those lists. So int from 1 to n. If this lists of I does not having any value, then we'll continue this one. If list of j, this is equal to null, then we have to give j equal to I. Else if list of j having the greater value of data, and lists of j having lesser value, list of I is lesser value dot data, then this j equal to I. Here if answer is null, first time I have to assign that answer equals to lists of j, and ptr is like current pointer, so I'll assign that also to the answer, or else I have to give ptr to ptr next and assign to the two ptr equals to ptr's next, which is nothing but lists of j. Okay, here once this is done, you have to move that whatever the node we were referring for, we have to move that nodes next. List of j equal to lists of j's next. Okay, here y error must have, here it is, data. Okay, ultimately we have to return that answer, so return answer. Okay, here in first line you need answer and pointer variable. For answer is for returning, and pointer is like current variable, and then we'll get the list of size as n, and if it is 0 we'll return, and while true means until some nodes are there we have to process this, and we are iterating in each of the list pointers and find out what's the smallest data. And then if it is answer is null, we have to, here I'll just give it answer is null, we first get that list of j and assign to answer and ptr for traversing, and if that not the case, ptr's next we have to travel, and we'll travel the current nodes next. When we have to break this is if this lists of j is null, we have to terminate this because we don't have any nodes to process. Break. Okay, now format the code and make sure you're calling this function here, x dot you can not x dot print. Inside of that you can call x dot merge k list, and you can pass this vector. Okay, now you can run. Okay, first 3 lines are 3 individual nodes, and this is the merged list. From you can see this 0 1 2, it's coming as sorted format. Okay, this is how you can solve this question, merge k sorted list linked list. This is second level of interview question. I hope you understood this problem and solution. Thank you for watching this video, and we'll meet in the next video.